Take a look at the 8 planets around us. The study of planets and exoplanets helps us understand the diversity in the universe. By studying different types of planets, their formation and evolution, we can infer the possibilities of what exists in the universe, including Earth-like planets, giant gas planets, ice giants, and more. In addition, a major goal of exoplanet research is to search for the existence of life in the universe. By analyzing the atmospheric composition, temperature, and other characteristics of exoplanets, we can look for signs associated with the presence of life, such as biomarkers or habitability. Finally, by studying planets and exoplanets in our solar system, we can shed light on the origin and evolution of our solar system. Understanding the theories and observations of planetary formation helps us to understand the characteristics of the Earth and other planets and their position in the universe. We will describe them in detail below. 1. The planets of our solar system. When we talk about planets, we are talking about the giant bodies of the universe. Planets are a special class of objects in our solar system that revolve around the sun and do not shine like stars. Let me explain to you the definition of a planet and the difference between planets and other celestial bodies. First, let's look at the definition of a planet. Imagine that planets are like giant spheres in our solar system that revolve around the sun, just like the Earth revolves around the sun. Planets have their own shapes and sizes. Some are very large and others are smaller. They also have different features such as large land and oceans on Earth, red deserts on Mars, huge clouds of gas on Jupiter, and so on. In contrast to planets, we have other celestial bodies such as stars and moons. Stars are the bright stars in our solar system that shine like the sun. Moons, on the other hand, are small celestial bodies that revolve around the planets. For example, Earth's moon is a moon. So there is a special relationship between planets and moons, just like the relationship between the sun and the Earth. Also, an important difference between planets and other celestial bodies is the way they move. The planets rotate around the sun, just like we ride a merry-go-round on a playground, and they also rotate around their own axis. This is why we have day and night, because the rotation of the planet allows the sun to rise and set in the sky. In addition, the planets have a special property in that they have their own gravity. You can think of gravity as an invisible force that keeps everything attracted to the planet. Just like when you play soccer on the playground, the soccer ball is attracted to the planet's gravity and keeps falling back to the ground. Finally, another important feature of planets is that they can have their own atmospheres. The atmosphere is like a coat for the planets. It surrounds them and protects them. While the atmosphere on Earth allows us to breathe fresh air, the atmosphere on Mars is very thin, so we can't breathe there. Overall, planets are special objects in our solar system that revolve around the sun and have their own shape, size, gravity, and atmosphere. Planets play a unique role in the universe compared to other celestial bodies. We hope that with these vivid descriptions, you will better understand the definition of a planet and how planets differ from other celestial bodies. There are many different planets in our solar system. They are divided into 2 categories: Earth-like planets and giant planets. Earth-like planets are those small planets like Earth that have solid surfaces, and giant planets are those huge gas planets that don't have solid surfaces. First, let's look at the Earth-like planets. Mercury is the closest planet to the Sun in our solar system. It is very close to the Sun. Mercury's surface looks a bit like the Moon, with lots of mountains and impact craters. Mercury is the smallest planet in our solar system, but it's no idle little star. It has a very special name, Mercury, but it has no water. This is because a long time ago, people thought that Mercury and Mercury's mythological story has something to do with, so it gave it this name. Because Mercury is so close to the sun, it is very hot. It's like the kind of heat you feel in the hot summer sun. Besides being hot, another interesting feature of Mercury is that it has a very long day. On Earth, a day lasts 24 hours, but on Mercury, a day lasts a full 59 Earth days. Mercury also has an interesting phenomenon called intraday progression. This means that the sun looks very strange in Mercury's sky. It rises in the east and then in the west, as if it were running around in the sky. This is because Mercury's orbit is very elliptical and its path of motion looks unusual. Even though Mercury is a tiny planet, it is very important to our research. Scientists send signals to Mercury through probes and then receive information back to learn more about Mercury's secrets. They study Mercury's surface features, atmosphere, and magnetic field in hopes of revealing its origin and evolution. Venus is one of the brightest planets in our solar system. It shines brightly in the night sky like a magnificent star. Venus is also one of our closest neighbors, like a friend who is very close to us. Venus is the closest planet to Earth in our solar system, and it has some similarities to Earth. First of all, Venus, like Earth, is a planet that revolves around the Sun. They both have their own day and year. However, Venus's day is longer than Earth's day, and it takes it 243 Earth days to complete one rotation. This means that Venus' day is longer than its year. Venus also has a special name, Venus. You may wonder why it's called Venus because it looks like a bright golden star. In fact, its name comes from Venus, the goddess of love and beauty in Roman mythology. It is believed that Venus is a symbol of the goddess Venus, so it was given this name. Venus is special not only because of its name, but also because of its climate. Venus has a very thick atmosphere filled with carbon dioxide. Do you know what carbon dioxide is? It is one of the gases that we breathe out. The carbon dioxide in Venus' atmosphere causes a greenhouse effect, like a giant greenhouse that traps heat on the surface of Venus. This makes Venus very hot, much hotter than Earth. On Venus, temperatures can reach over 900 degrees Celsius, enough to cook a steak. Another interesting fact is that Venus has many volcanoes on its surface. These volcanoes erupt magma and gases that make up the mountains and plains on the surface of Venus. Some of the craters are so large that they look like a giant volcanic pot. These volcanic activities have left the surface of Venus covered with craters and volcanic eruptions, creating a unique landform. Despite the harsh surface of Venus, scientists are still intrigued by it. They send signals to Venus through probes to learn more about the planet. By studying Venus, they hope to reveal its origin and evolution, as well as learn more about the planet's climate and atmosphere. Mars is the second closest planet to Earth in our solar system, and it is one of the planets that humans are most concerned about. It resembles a red planet and sometimes looks like a bright red shining star in the night sky. Mars is named for its color, and its surface has a reddish hue, like a huge red desert. This is because the soil of Mars contains a lot of iron oxides, which we often call rust. You can imagine a red desert stretching into the distance under the light of the sun, and this is what Mars looks like. There are some similarities between Mars and Earth. First of all, Mars has its own year and day, except that the Martian year is much longer than Earth's, about twice as long. And the difference between a Martian day and an Earth day is not that much, just a little bit more time. Mars also has some very interesting geographical features. For example, it has the tallest volcano in the solar system, Mount Olympus. This volcano is so huge that it is taller than any other volcano on Earth. One can imagine this huge volcano towering over Mars, and its sheer size is awe-inspiring. In addition to volcanoes, Mars has some deep canyons and wide plains, and these landform features give Mars a unique beauty. You can imagine walking around Mars and seeing spectacular canyons and wide plains that will overwhelm you with their scenery. Another striking feature of Mars is that it has ice caps at its poles. These ice caps are mainly composed of ice and frozen carbon dioxide. When the seasons change on Mars, these ice caps melt or freeze, just like the snow and ice on our planet. This is an important form of water presence on Mars and is significant for future human exploration and survival on Mars. Scientists are curious about Mars and are sending signals to Mars through rovers to learn more about its secrets. They hope to find water on Mars, learn about its climate and geological activity, and even look for signs of whether life exists on Mars. Next, let's take a look at the giant planet. Jupiter is the largest planet in our solar system, and it's a huge and spectacular giant. It is much larger than the other planets, even larger than the other planets combined. You can imagine seeing a huge bright spot in the night sky that is Jupiter. Jupiter is a gaseous planet that doesn't have a hard surface, but is made up of gases and liquids. It is made up mostly of hydrogen and some helium, just like a giant balloon. If you were able to stand on Jupiter, you would feel surrounded by an infinite amount of gas with no solid ground to step on. Jupiter's appearance is spectacular. It has a bright great red spot, which is a huge storm that has been around for hundreds of years. This great red spot is larger than Earth and can hold several Earths in size. You can imagine observing this huge red vortex from Jupiter. It's a breathtaking sight. Besides the great red spot, Jupiter has many other storms and clouds. These clouds show different colors and textures, from white to yellow and even brown. This gives the surface of Jupiter a colorful visual effect, like an abstract painting. Jupiter also has some special moons that are like sidekicks that surround it. The most famous of these are the Galilean moons, which were first discovered by the Galilean Astronomical Telescope. There are 4 Galilean moons, and their names are Io, Europa, Ganymede, and Callisto. These moons are noted for their diverse surface features and the possible presence of liquid water. Jupiter also has a very strong magnetic field, much stronger than Earth's. This magnetic field creates a huge magnetosphere that protects the space around Jupiter from the solar wind. The solar wind is a stream of charged particles released by the Sun, and without Jupiter's magnetic field, these particles would have a serious impact on the environment around Jupiter. The study of Jupiter is important to our understanding of planetary formation and evolution. Its great mass and unique features provide valuable information. By studying Jupiter in depth, we can better understand the evolutionary history of our solar system, as well as the formation and evolution of other planets and moons. Let's turn to Saturn. Saturn is a very special planet in our solar system that is famous for its rings. Saturn is like a giant halo around its planetary body, the only ring system in our solar system that is so obvious. The appearance of Saturn is very striking. It is a gaseous planet, composed mostly of hydrogen and some helium, like a giant balloon. But unlike the other gas planets, Saturn has a wide and spectacular ring system around its exterior. These rings are made up of ice and rock fragments that form a series of ring blocks, as if uncountable brilliant jewels surrounded the planet. Saturn's rings are very thin, but they are very wide. Imagine seeing a huge planet in the night sky surrounded by a ring of magnificent lights that shine brightly. It's a spectacular and beautiful sight. In addition to the rings, Saturn has some interesting features. It has many moons, the most famous of which is Titan, also known as Titan. Titan is one of the largest moons in the solar system, and it is larger than many of the planets. Its surface is covered with a thick atmosphere, similar to that of the Earth. Titan is of great interest to scientists because it may have liquid water and organic compounds, which makes it a potential target in the search for extraterrestrial life. Saturn also has some interesting storms. There is a huge storm in its polar region known as the Antarctic storm. This storm is a huge vortex that has persisted for many years. Its size and intensity is amazing and adds a mysterious and spectacular atmosphere to Saturn. Saturn also has a powerful magnetic field that acts like a large magnetic field. This magnetic field protects the space around Saturn from the solar wind. The solar wind is a stream of charged particles released by the Sun, and without Saturn's magnetic field, these particles would have a serious effect on the environment around Saturn. Saturn is a fascinating planet with rings and other features that set it apart from other planets in our solar system. By studying Saturn, we can better understand how planets form and evolve, as well as learn about the characteristics of the giant gas planets in our solar system. Its spectacular sights and mysterious features have inspired human curiosity about the universe and have provided us with invaluable opportunities to explore the universe and learn about the other planets in it. Let's talk more about Uranus. Uranus is a planet in our solar system that is an ice giant, also known as an ice giant. Unlike the other planets, Uranus has a very distinctive color that gives it a pale blue appearance, as if it were a giant ball of ice. Uranus is composed of gases and ice, mainly hydrogen and helium, as well as frozen ammonia, methane, and water. These frozen substances give Uranus its unique appearance and character. If we could stand on Uranus, we would see a huge ball of ice surrounded by floating ice crystals. Uranus is the most tilted planet in our solar system, with its axis tilted almost perpendicular to its plane of rotation. This means that Uranus' north and south poles face the Sun alternately in different seasons. This tilt results in extreme seasonal changes, just like summer and winter on Earth, only more extreme. Uranus' atmosphere is also very interesting. Its atmosphere consists mostly of hydrogen and some helium, but there is also some methane and other hydrocarbons. These substances react chemically when exposed to sunlight, creating the unique colors in Uranus' atmosphere. It is the presence of methane that gives Uranus its bright pale blue color, giving it a mysterious and fascinating appearance. Uranus also has a series of rings, and although its rings are not as pronounced as Saturn's, they do exist. These rings are composed primarily of ice and some rock fragments that surround Uranus' planetary body. The mechanism by which these rings form is still not entirely clear, but they add a unique charm to Uranus. Uranus also has a number of moons, the most famous of which are Titania and Oberon. Titania is the eighth largest moon in our solar system, and its surface is covered in ice, giving it a pale color. Oberon is the largest moon of Uranus, and it is also the second largest moon in the solar system. Oberon has some canyons and mountains on its surface, giving it a spectacular and mysterious appearance. The study of Uranus is important to our understanding of planetary formation and evolution. Its icy composition and special tilt provide a unique perspective. By studying Uranus in depth, we can better understand the evolutionary history of our solar system, as well as understand the characteristics and formation mechanisms of ice giants. A final word about Neptune. Neptune is a planet in our solar system that is also an ice giant and is considered one of the most distant planets in our solar system. The planet is named after the god of the sea in Roman mythology because its colors and features are somewhat similar to the oceans. Neptune has a fascinating appearance. It is composed mostly of gas and ice, similar to Uranus. However, Neptune has a much deeper blue appearance, giving it a mysterious and grandiose feel. This is due to the fact that its atmosphere contains some methane, which absorbs red light and reflects blue light, giving Neptune this unique color. Neptune also has a range of meteorological phenomena. There are strong storm systems in its atmosphere, the most famous of which is the Great Dark Spot. The Great Dark Spot is a huge storm that lasted for decades. It is one of the most intense storms in the solar system and has caused enormous disturbances in Neptune's atmosphere. Scientists have become interested in the formation and persistence of these storms to better understand Neptune's climate and meteorological phenomena. Similar to Uranus, Neptune has some rings, although they are not as pronounced as those of Saturn. These rings are composed mainly of ice and rock fragments that surround Neptune's planetary body. The origin of these rings remains a mystery, but they add a unique sense of beauty and mystery to Neptune. Neptune also has a number of moons. The most famous of these are Triton and Neptune, which are among Neptune's largest moons. Triton is one of the coldest moons in the solar system, and its surface is covered by a thick layer of ice. Triton also has a number of canyons and mountains on its surface, giving it a spectacular and peculiar appearance. Neptune's other moon, Neptune, is relatively small, but also has some interesting geological features. Studying Neptune is important to our understanding of how planets form and evolve. Its icy composition, atmosphere, and storm systems provide valuable information. By studying Neptune in depth, we can better understand the evolutionary history of our solar system and provide important references for exploring similar planets and planets in our galaxy. So, the planets in our solar system can be categorized into Earth-like planets and giant planets. Earth-like planets have solid surfaces like Earth and include Mercury, Venus, Earth, and Mars, while the giant planets have no solid surface and include Jupiter, Saturn, Uranus, and Neptune. Each of them has its own unique characteristics and composition, giving us a deeper understanding of the planets in our universe. 2. Planet formation and evolution. When we talk about the formation and evolution of the planets, we are talking about how they came into existence and developed into what they are today. First of all, there are two main theories about planet formation. The first is the core coalescence model. It suggests that the formation of planets began with a giant cloud of gas called a primordial nebula. You can think of the primordial nebula as a giant cloud of fog. In the primordial nebula, there is a lot of gas and tiny particles. These particles gradually came together to form a disk-like structure called a protoplanetary disk. It's like playing with sand, where you gather the sand together to form a small hill. The second theory is the collision and accumulation model. It suggests that planets form through a process of collision and accumulation. In the protoplanetary disk, there are many tiny particles which are called planetary seeds. These seeds are very small, like a grain of sand. When these seeds collide with each other, they stick together and form larger objects. Just like toy building blocks, you stack pieces on top of each other and end up with a big building. Next, let's look at the evolution of planets. Once planets form, they go through both internal and external evolution. Internal evolution refers to changes within the planet. Planets have lava and rocks inside them that melt from the heat, just like molten metal in a furnace. These lava rocks form magma, which then cools and hardens. There are also crustal movements inside planets. These internal changes can change the appearance and characteristics of the planets. On the other hand, external evolution refers to changes in the planet's surface and atmosphere. A planet's atmosphere is made up of gases, just like the air around us. These gases are subject to change by the sun and other factors. Some planets' atmospheres get thicker and some get thinner. These changes affect the climate and surface characteristics of the planets. Overall, the formation and evolution of planets is a very complex and interesting process. They can form either through core coalescence models or collision and accumulation models. Once formed, planets undergo internal and external evolution, including internal magma and crustal movements and external atmospheric changes. Through these processes, planets gradually become distinctive, with unique features and climates. We hope that these vivid descriptions will help you better understand the process of planetary formation and evolution. 3. Exoplanets. Now let's talk about exoplanets, which are planets outside our solar system. They are planets that exist around other stars, just like our Earth around the Sun, except that these planets surround other stars. First, let's explain the concept of exoplanets and the criteria for recognizing them. Exoplanets are planets that exist in other galaxies that are not part of our solar system. By observing stars in other galaxies, scientists have discovered planets orbiting them. These planets may be similar to our Earth or very different. So, how do scientists discover exoplanets? Let me tell you about some of the major discovery methods and important milestones. First, there's a method called solar transits. Just as the moon blocks out the sun when it passes over it, when a planet passes in front of the star it's orbiting, it blocks out some of the star's light. Scientists can infer the presence of the planet by observing changes in the brightness of the star. This is similar to how the ground behind you dims when you cover the sun with your hand. Another method is the radial velocity method. When a planet orbits its star, its gravity causes the star to wobble slightly. Scientists can infer the presence of a planet by observing this tiny wobble of the star. You can think of this process as a small child swinging on a swing set and his friend observing the swing and knowing he is there. There is another method called the light variation method. The light variation method is a way of discovering exoplanets by observing changes in the brightness of a star. When a planet orbits a star, it causes the star's brightness to change. Scientists determine if a planet exists by observing the pattern of this change in brightness. You can think of this process as if you were playing in the sun and there were clouds that blocked the sun from time to time, making the light dimmer. Now let's look at some important milestones. In 1995, scientists made a very important discovery when they found the first planet orbiting another star. The planet was called 51 Pegasi b, and it orbited a star called 51 Pegasi. This discovery caused a huge stir because it proved that Earth-like planets don't just exist in our solar system. In the following years, scientists discovered more and more exoplanets. They found a wide variety of planets, some larger than Earth, some very close to their stars, and some very far away. These discoveries have made our understanding of the universe richer and broader. So, exoplanets are planets that exist in other galaxies. Scientists use methods such as the transit method and the radial velocity method to discover these planets. Important milestones include the discovery of the first exoplanet in 1995 and subsequent discoveries that have led to a deeper understanding of the universe. The discovery of these exoplanets has made us realize that there are more planets in the universe, and there may be other chances for life to exist. Now let's talk about ways to study the characteristics of exoplanets. Through observations, scientists can study characteristics such as the mass, orbital period, and orbital eccentricity of exoplanets. They can infer the mass of a planet by measuring the star's wobble, just as we can tell the weight of a person sitting on a swing set by observing its swing. The orbital period is the time it takes for a planet to make one complete orbit around a star, while orbital eccentricity indicates the shape of a planet's orbit. By observing these features, scientists can learn about the patterns and nature of a planet's motion. In addition, scientists study the atmospheres of exoplanets to learn about their composition, temperature, and atmospheric conditions, and to look for signs of the presence of life. Just as we predict the weather by observing the color, shape, and movement of clouds, scientists analyze the chemical composition and temperature distribution in exoplanet atmospheres to infer weather conditions are suitable for life. These studies can help us better understand whether other life forms exist in the universe. 4. Kuiper Belt objects and their discovery history. Now let's talk about Kuiper Belt objects and their discovery history. First, let's describe the location and composition of Kuiper Belt objects, a region at the edge of the solar system that is quite far from the Sun. You can think of it as the boundary of our solar system, like a giant circle around our sun. The Kuiper Belt is full of small objects, ranging in size from a few tens of kilometers to a few kilometers. These objects are made up mostly of ice and rock, kind of like an ice cream ball with some rocks on it. Next, let's outline the process of discovery in the early 20th century regarding objects at the edge of the solar system. In the past, scientists didn't know much about the edge of the solar system. It wasn't until the early 1900s that they began to investigate whether other objects existed further away from the Sun. The earliest discovery was made in the 1930s when a scientist named Clement Wins came up with a theory that there might be some unknown objects at the edge of the solar system. He hypothesized that these objects might be remnants left over from the formation of the solar system. Then, decades later, in 1992, scientists David Jewett and Pearl Bowerman made the first discovery of an object known as 1992 QB1 in the Kuiper Belt. This was the first discovery of an object at the edge of the solar system, and its discovery caused a sensation in the scientific community. Think of it as if you were looking for a shell on the beach and suddenly found a particularly beautiful one. As technology improved, scientists began using more powerful telescopes and detectors to look for more Kuiper Belt objects. Over the next few years, they discovered many new objects one after another, including some very large ones, like Pluto. These discoveries added to our understanding of the edge of the solar system. So, to summarize, Kuiper Belt objects are located at the edge of our solar system and are composed mostly of ice and rock. At the beginning of the 20th century, scientists began to investigate whether other objects existed at the edge of the solar system. The earliest discovery was made in 1992, when scientists found an object in the Kuiper Belt. Subsequently, they used advanced technology to discover more objects one after another, unraveling the mystery of the edge of the solar system for us. 5. Future directions of research in astrophysics. First of all, let us talk about the research prospects for searching for the location of life and for an extra-systemic Earth. Scientists have been trying to find out whether there is a possibility of life elsewhere in the universe. They use a variety of methods and instruments to search for Earth-like planets that may have conditions suitable for life. Imagine assuming that we have a super powerful telescope that can see very far away. Scientists use this telescope to look at planets in other galaxies, searching for planets that are as suitable for life as Earth. They will look at the atmospheres of these planets to see if there are gases like oxygen that are associated with life present. At the same time, they will also look for signs of liquid water, as water is one of the important factors for the existence of life. Next, let's explore the application of in situ compositional analysis to the development of future space telescopes. In situ compositional analysis refers to the chemical and physical analysis of planets, comets, or other celestial bodies directly in space. Scientists use probes and detection equipment, send them into space, have them land or fly by the target object, and then analyze them in detail. We can think of this process as a space expedition. Scientists would send a small robot or probe, and they would go and survey the surface of other planets. These robots would collect samples and then use various instruments to analyze their composition. In this way, scientists can learn about the composition of other planets' atmospheres, the geological features of their surfaces, and whether there are signs of life. In the future, scientists are also developing more advanced space telescopes that will be able to observe various objects in the universe more clearly. These telescopes will allow us to see galaxies farther away and explore more uncharted territory. They will help scientists gain a deeper understanding of the origin of the universe, the evolution of galaxies, and the nature of mysterious objects such as black holes. That's all for this episode. Thanks for watching.